Hello everyone. So today will be a theoretical video, and in this lecture we'll be discussing about harmonics. We must have come across situation like this where there is a spring block system and this is a frictionless floor where mu equals to 0 and damping is negligible. The spring constant is k and mass of the block is m. So we write that omega is equals to root k by m. Easy peasy because it's of form d2x by dt2 plus omega square x is equals to 0. This is the form of equation we get while solving this system. Now we consider another system where there are two blocks, and for now I am assuming both have some mass m and they are oscillating in a steady state. There can be two possibilities. Case 1 is something like this. The block A and B as mentioned. The block A is displaced by some distance x and block B is displaced by distance x in the same direction. Spring constant is k. In this case, the angular frequency comes out to be root k by m. In second case, we displace them by some amount x by the same amount x but in the opposite direction. In this case, omega comes out to be root 3k by m. Can there be another modes? Apparently, no for this scenario. Well, one postulate one must remember, that is number of modes is equal to number of distinct masses, right? Now one may ask about this situation. So here there are also two masses, but here is only one mode possible, that is this by x and another by x, or they doing SHM in the center of mass field. So the other mode is something like this. This will also displaced by some distance x, this will also displaced by some distance x. In this case, omega comes out to be 0. Pretty surprising, but this is also a solution to this given system. Now how to find all such solutions? Let us discuss through a simple example. Suppose this is my system in consideration. Mass m, 3 springs of spring constant k. Suppose I consider this to be origin and I displace it by x1 and the other block by x2. I can write mx1 double dot is equals to minus 2kx1 plus kx2. Similarly, for the second block, I can write mx2 double dot is equals to minus 2k x2 plus kx1. Rearranging will get plus kx1 minus 2k x2. Okay. Now we have to involve concepts of matrices in this. To deal with this situation, we have to involve the concepts of matrices. Let us assume a matrix x is equals to x1 x2. So I'll write m x1 x2 is equal to minus 2k k k and minus 2k into x1 x2. Well, it will be x1 double dot in the left hand side. Now I assume a solution x1 is equals to a cos omega t plus b sin omega t. Yeah, a1 cos omega t plus b1 sin omega t. Similarly, x2 is equals to a2 cos omega t plus b2 sin omega t. I can say x1 double dot is equals to minus omega square x1 and x2 double dot is equals to minus omega square x2. So I can say m omega square negative of m omega square x1 x2 is equals to minus 2k k minus 2k into x1 x2. So I can write it further like x1 x2 into minus 2k k minus 2k plus m omega square into I, where I is a identity matrix of order 2 cross 2. Now, if you have come across matrices, then you must have come across this equation Ax is equals to lambda x. Then this implies A minus lambda I x is equals to 0. If this is valid for all x, then this implies that mod A minus lambda I is equals to 0, right? The similar thing we'll be doing in this case. I can say minus 2k plus m omega square whole square minus 2k plus m omega square. Now I am not opening the determinant. K and k determinant to be 0. I can say k plus minus k is equals to m omega square minus 2k. From here omega is equals to root 3k by m or root k by m. Now that's a pretty interesting result. Well, this method is applicable to any system, any number of particles, let it be. We can apply this method. In case of a string, if you observe a string, well, how many modes of vibration are there? There are infinite modes of vibration because each segment individually acts as a distinct mass. That is why there are infinite modes. We say in case of a standing wave where both the ends are fixed, lambda is given by 2L by n. In case of a standing wave where two ends are fixed, the L is the distance between the fixed points. So we can also solve other problems like any number of systems like this pulley, and the pulley also has some mass m3, and this is of mass m, and you are just pulling it away. This is also applicable. Well, you must try to explore as much as possible in this concept so that it you get a grip about it. Thank you. Have a nice day.